I'm Matt Parison, and I'm on the track team here, and I long jumped in high school. I came up with the idea to make the long jump pit leveler, and I was working with the design and testing of it.
Hi, my name is Alexa Langenfeld. I mostly worked on the prototype and report, and this project related to me because I did long jump in high school and I played college soccer.
Hi, I'm Georgia Kiko. I worked on the proposal and report for this project. I long jumped in high school and I also played college volleyball.
Hello, my name is Jacob Hutcherson. I'm on the track team at the University of Akron. I was in charge of building, purchasing the materials, and testing the leveler.
Traditionally and still today, long jump pits have been raked by hand with pit rakes and shovels. Using this method, it's difficult to ensure that the pit is raked evenly or at the same level each time. Additionally, raking by hand takes up a considerable amount of time between jumps since the rake is only typically 3 feet in width. This can also create safety issues for the rakers as they often have to step into the pit to reach the center, and also unlevel and clumpy sand can be a danger for the jumpers. We wanted to come up with a design that would level and rake through the pit in one swift run down and back. The device would require only 2 people on either side and much less time between jumps. It would also ensure a level and evenly spread pit to keep the jumpers safe. Our team did extensive research into the differing sizes of long jump pits. We found that this model is the most standard, being 2.75 meters wide and 7 to 9 meters long. As previously mentioned, long jump pits have been raked by hand, taking an extensive amount of time and number of people to complete between each jump. There is also a lot of room for inconsistency and error. So how can we make this easier and more applicable? We started off our design process thinking we might motorize the rake. After considering indoor and outdoor changing environments and the want to make this device applicable to existing pits, we began to think more manual. These next designs were designed to be a 2-person push machine and look more similar to our final prototype. We wanted the handles to be adjustable to be able to move down one way and back the other way in the pit. We had also talked about having our model bend and collapse in the center for ease of transportation, as seen in the drawing shown. Wanting the device to be relatively lightweight, we decided that the best material for the main piece would be aluminum. Because we are a self-initiated project, we tried to keep our materials as low cost as possible and keep our design simplified. Using 4 aluminum L brackets and bolts, we created our main body piece. We were then able to attach our rake pieces to the front. After some measurements considering the pit depth and width, we created the wheel attachments and attached the handles at an angle that allows the 2 rakes to wheel the device forward and backward without the rake teeth dragging on the ground. Once we began some testing, we attached the leveler to the front of the rake pieces in a way that when the device is pulled, the sand is raked first and leveled after. The material that we used for the leveler is a stiff strip of rubber-backed carpeting. Before brainstorming our parameters of success for this project, we came up with a survey to get the input of Akron's long jump and triple jump coaches. The survey questions being: what is the most important aspect of the pit after raking? Do you think pit smoothness or levelness affects measured jumps? What is the biggest obstacle you face when it comes to competition or meets and you use the current raking method? Time, amount of people, inconsistency? What do you think about having a leveler or rake half the width of the pit? Would it be hard to store? What would you say is your biggest worry with this leveling rake we are designing? What are you most excited for? After considering the coach's feedback and better conceptualizing our project idea, we thought up our parameter or metrics of success, these being: sand will be evenly distributed within 1-inch depth, speed up the process of raking by 5 to 10 seconds per jump, will use at least 1 less person to officiate the pit area, and device in its entirety weighs less than 60 pounds. Given my team's experience in the long jump event in both the high school and college level, we decided to include heart rate exertion into our testing because most pit rakers tend to be older volunteers. To show exactly how we went about our testing, here's a clip of Alexa performing a long jump. As you can see, the jumper starts from the end of the runway, sprints towards the pit, and takes off on one leg, propelling herself into the pit. She then swings her legs in front of her and lands in the sand. We had her do this multiple times. The next clip shows Jake and Matt raking the traditional way. As you can see, it takes a lot of physical effort and time to make sure the pit is level. This next clip shows Jake and Matt again raking after a jump, but this time using our enhanced long jump rake and leveler. They tilt and roll the device to the front of the pit, tilt the device with all 4 wheels back on the ground, and pull the rake backwards. We found this to be the most efficient method of use. This first photo shows the condition of the pit after a jump. This next photo shows the condition of the pit after raking the traditional way. The final photo shows the pit after using the enhanced rake 2 times through. As is seen, the enhanced rake does a much better job raking through the clumps and leaving a smoother surface. For our measured testing, we did 15 trials for each of the following. Firstly, we tested the time it takes to level. For the traditional raking method, it took on average 37 seconds. The enhanced rake leveler took an average of 24 seconds. That's a 13-second difference in average between the two methods, which proves our goal of decreasing the time to rake by 5 to 10 seconds each jump. Next, we tested the depth of the highest to lowest point after raking. This could be a footprint dent or a mound of sand left over after raking. Traditional raking showed about a 1.5-inch depth difference between the highest and lowest point. The enhanced rake leveler showed about a 3/4 of an inch difference. This helped to prove our goal of sand being evenly distributed within 1 inch in depth. Lastly, as we previously mentioned, we tested the heart rate exertion during both raking methods. During traditional raking, the average heart rate was 105 beats per minute. With the enhanced rake leveler, the average was a lower value of 86 beats per minute. This helped us to prove that our enhanced rake leveler is less physically exhausting, which would be beneficial to some of the older volunteers that help rake. The final thing we recorded was the best number of times to run the rake through for the smoothest pit. Here you'll see the before picture, the pit after 1 run through, the pit after a second run through, and the pit after 3 runs. As you can see, the pit is almost perfectly smooth after the 3rd run. In final conclusion, we found that our device performed successful in all 4 of our parameters of success during trial. The device in total weighs less than 60 pounds, the time to rake was decreased by more than 10 seconds with the enhanced method, the sand is more evenly distributed within 1 inch, it only requires 2 people total to rake and level the pit, and additionally, it is less physically exhausting for the rakers. We are very pleased with the way our project turned out and excited to see it in use at Akron track meets. Thank you for watching, and go Zips!